Alright, today is June 13th, 2022. It is day 330 of data science, and it is also a Monday. Okay, so today the goal is to attempt to do two things. First, use Parsehub, which is a web scraping software that scrapes data from a website or anything and then turns it into a CSV file so that the goal is to open it in Google Colab, because the honest truth is that I am very lazy right now and I do not want to manually write a data frame and put in all these numbers when I can just use Parsehub and it'll just scrape it for me and make it into a data frame for me, so I don't have to do it. Alright, and then second thing is I want to practice creating an SQL table since like 2 days, no, that was yesterday. Yesterday I learned how to do or create an SQL table, so today I'm practicing and I'm trying to see if I could do it without looking back at my code, see if a miracle happens. And yeah, so we'll start with Parsehub. So I'm gonna do new project, and then I should probably get the URL for the site and paste it in there, and then wait for it to load. Right. I'll unpause it once it loads. Alright, so I'm going to scroll down all the way until I find the data frame that I want, or the data that I want. Alright, and I haven't used this since like my research project. I've only used this like 2 times. My first when I first found out about it, and then my second time my research project, and this is my 3rd time, so let's see if I remember anything. Okay, so this. Add action. Select this. I think I'll select all the times first. And then I'll select this time. There we go. So I'll call this now. Okay, so this happened real quick. So basically what I did is I went to this over here and I clicked on select and then I selected the times, right? And then what I did was I selected it like one more time, and then what Parsehub does, it's smart, right? So it's just like, oh, so this is what you want, right? Like each value in this column, and then it just selects the rest of them for me, which is 13. And so I'm going to go over here to where selection 1 is, and I'll just give it the named time because that's what the column name is. Alright, and then you can see it over here. Down here in the CSV Excel / whatever. Okay, yeah. Anyway, I'm do the same thing for proportion. So let's see. I'm going to select. So I said add select, and then I'll do one here, and then I'll wait for that to add. And then I'll select another one here, and I'll wait for that one to add. And then I'll call this section proportion or prop, whatever it is. And that's all I need. I don't need the log stuff because that's I'm gonna do that manually. All right, that's all I needed. It should pop up any second now. Weird. Why did it skip? What? 1, 5, 15, 30. Let me see. 0.84. Where is it? That's weird. Time 13. Why isn't it extracting everything? Oh, there we go. But then why does this one end at the... It's so weird. Prop? And then... calling this prop. Why is it starting at the bottom? It's so odd. It's really weird. How do I I fix this? I could always just fix this in pandas. I could just make 2 separate series and then just join them together again. I don't really need it to be fixed here because I don't know what's going on right now. Get data. I mean, I did get the data, right? I have the columns, I have the data. Why is the prop starting when the time ends? Like, what? Tell me how that works. Maybe if I move it, select prop. Nope. That's gonna. I'm so confused. What did I just do? What? Bro, are you like kidding me right now? I kid you not, I don't know what I just did, like, at all. How odd. At this point, I'm just experimenting. Okay, so maybe I'll start from the beginning. I'll do add action to page, and I'll do select. I'll just target all of these elements here. Right there. Okay, call it time. And then maybe I'll do a relative select. So that's how you do it. Right, makes sense. Okay, so instead of it being like 2 different things, I'm saying that time, or like that certain one, is relative to the 0.84. There we go. See? Okay, we got it. So now I'm going to call it prop or proportion. Alright, and then I'm just going to click on get data, right? Because I got my data. I don't need the last column because that's just, I'm going to do that. Like, that's the whole purpose of this, so that I could do that. And then this should just be loading. Alright, and now it's ready, so I'm just gonna click on CSV and I'm gonna save the file. Do I want to open with? No, save file. Run results CSV. I should probably have renamed that. Oh, I can. Okay, great. I'm gonna go to my desktop and I'm gonna put it there. I'm gonna call it what is it called? I'm just gonna call it by the name. Nope, the date, not the name. 6/13/22. D for data, because I use this to call my Blender stuff. So I'll save that there. All right, and now I can go to Google Collaboratory and I can go to my files and I'm gonna go here, so little folder icon, go to my desktop, upload my CSV, go over here, copy the path, and then import, that's not how you spell import, pandas as pd, do pd dot read CSV, read in my data, set it equal to a variable maybe called data, and then maybe do data.head to print out the first 5 rows of that data. And here's the data, right, that we have right here. I was just too lazy to manually write that, so okay. Only thing is, we also have our indices, right, the 0, 1, 2, 3, 4, blah, blah, blah. All right, so now that I have the data, I kind of want to look into this. So this person, right, plotted this data, right? So I'm gonna do import Seaborn as SNS, and I'm going to just what? I'm going to plot the scatter plot of the data, and set x is equal to data time, and y is equal to data prop. Right. What now? Time. Is it not called time? Oh, time name. Ew. I forgot it does that. We can fix that real quick. I'm pretty sure it's either names or columns. I forgot what it was. Let me see. Time. Prop. Maybe that was, nope, that's not what it was. Was it this? Oh, there we go. Yeah, but then, ugh, this sucks. Okay, data dot, data 0? No. Data dot drop axes equals 0. What do I need? 0. Great. How do I drop again? Data 0 axes. The first row 0 in place equals true. There we go. Okay. So what I did was I changed the name of the columns because they were weird, and then I also dropped the first row since it was also weird. Okay. We're good. And now run that, and it should plot the scatter plot. What the heck? Why is it linear? It was supposed to not be linear. What? Don't you tell me. No way. What? That doesn't make sense. Was it the visit plot that they did? Fitted line plot? Don't tell me I did the wrong data set. No, that's the right data set. So then what did I do wrong? Why is it linear? It's not supposed to be linear. What? Fitted line plot? Interesting. Oh well, I don't really know what just happened. Apparently this is the linearized data. That's so weird. Wasn't it supposed to be curved? This is the data after it's linearized, after you apply the log. So why is it like that? Create a newly transformed predictor called inTime. Whoops. That's weird. Anyway, it doesn't really matter. I learned something new today. Actually, I didn't learn. I just practiced what I already knew, which was Parsehub, right? And then what else? Yeah, that's pretty much it. Let me see. Do I want to continue with this? it is a linearized data set, but why is it like that? It's supposed to be, I thought that this data represented this graph up here, the first one that over here. But it seems to be representing this here, this graph over here. Which is weird because this is the result, the end time, not the, you know, I don't even know, bro. I don't know. Whatever, it's okay. At least we plotted something. Alright, we're gonna leave that as that, and then I'm also going to go to like this SQL online IDE because I haven't found a good one yet. Honestly, like Google Collaboratory doesn't do SQL. Deep Notes kind of does SQL, but it also doesn't. So I'm gonna just do this thing I found yesterday, and I'm gonna try to do some thingy or whatever. Okay, so I believe it starts with create table, and then the table name. I'm gonna call this, what table should we do? Let's see, brands. Alright, and then, let's see, primary key. Alright, so then I do the column names. So I do, okay, ID, and then I do, what is it, primary, no, first I do the data type, so it's an integer, and I do primary key or something, and then, okay, that's the ID, and then the name of the brand, so that's going to be text, then possibly the, I don't know, money, that doesn't even make sense, like the amount of money they make or something, or their worth. Alright, and then I'll do insert into brands, values, and I'll do the first one to be, let's say Gucci or whatever, and then I'll say like, we're gonna go small, $10, bro, just $10. I'll just copy and paste that. And then I'll do like, okay, the second one can be like, Old Navy. We'll say that's worth $1. And then we'll say, what's another brand? Walmart or whatever. Worth $7. And then select everything from brands and then run that. What? It's right there. What do you mean? Gucci? What do you mean there's no such column named Gucci? I'm not saying a column. I'm saying that oh! Forgot. I have to add quotations. Reminds me of when I started learning Python. Don't forget your quotations. Run. Ugh, great. A table brands already oh, okay, let me just reload. This thing is really weird. This new thing, because in Khan Academy, you could rerun it as many times as you want. Okay, there we go. So, yay, I created an SQL table. Don't forget your quotations. What else? I feel like today was very, like, I want to do more. Let's do more. Let me see if I can do what I could do. I want to do the residual plot. Let me do SNS resid plot. Or is it resid? It's either resid plot or resid. Great. What is it? Really? SNS dot re. Oh. Really? Did I not import C1? I am pretty sure. See, I was right. Please. Oh, rude. What do you mean? Loop of function does not support argument one of string which has no callable condition function. What do you mean? Oh, this thing is so irritating. What? Loop of view function does not support argument 1 of type string, which has no callable conjugate method. Since when did I... Can you just please work yourself out? Really? Really? Well, then what did I do the other day? Oh. Oh no, I still did a visit plot. Yeah, what the heck? And it was the same thing. Rude. Is it because the data's already linear? No, it doesn't matter. There still should be... Let me just copy this and paste this and then do visit plot. What? I've never heard of this one before. Let's do Stack Overflow. So I'm assuming, right, it's because they're floats instead of integers, while I think over here, these were all integers. So I believe that the visit plot doesn't take in floats and only takes in integers. So what do I do? Like, what the heck? So is it just not gonna work? Like what? Do we not do visit plots of decimal thingies? Decimal function, what? Decimals? Decimal statements. Really? Then it's just all gonna become like 1 and zeros. Like what? That doesn't make sense. Yeah, no thank you. We're gonna leave it like that. So instead of that, maybe I could do a reg plot. Or is it not gonna work also? Why is it capital letters? Bro, are you serious? You know what? It's fine. It's fine. If it doesn't want to work, it's okay. You know what I'll do? I'll just search up another data frame. Data frame or data set for also. No. No, you know what? I have the perfect thing. I have a data set, the student data set. I always use it. Well, I always used to use it. I haven't done that. Or haven't touched it. Hold on, where's my data? I know I have it somewhere. Desktop, data, data sets. I have 5,000 of them here. Student grades. No, it was some student performance. Oh, I love this data set. Alright, right click, copy the path. Okay. Great. So I'll take the math score and reading score. So what I'll do is I'll take basically data. I'll do SNS dot scatter plot and plot the relationship between the math score. So maybe I'll use the math score to predict the reading score. Actually, you know what would make sense? If the reading score could predict the math score. Or just the writing score could predict the reading score. And that. Okay. Oh, this data set is like the most beautiful thing I've ever seen in my life. Like literally, like I say that a lot, but no bro. Like this is so beautiful. Like look how linear that looks. It looks like a shark, like a fish. It's so beautiful. Like oh my god. Alright. Anyway, so we have that, right? And we can clearly see that the relationship is linear. And so because of that, we can use the line, the LSRL, that you'll see in 1 second to predict the future values of the what do you call it? The reading score. Only thing is you can barely see it. So how about we change the color? I forgot how to do line KWS. Let me go back. Oh my god, I didn't even do it. Hold on, it was day 90, right? How do I get there? Okay, data science 1. We'll wait 1 second. Okay, any day now. I'll pause and come back. Alright, I found it. Turns out it's day 93, not day 90. This is the piece of code that I wanted over here. So line KWS. I probably should do research on it instead of just always copying and pasting it. Because I don't even know what it means. But like, what is, I always see like, you know what, never mind, I'm not even gonna get into it. I'm gonna go here, paste that in there, and then that should change the LSRL to red. You're kidding me, bro. What now? Line KWS. Great. Is it only for... That doesn't make sense. I literally just used it. Like, what do you mean there's no property? Whoops. Oops. Okay, yes. Oops. Hold on, that's my bad. Meant to put it over here. Don't know how that ended up over there. Okay, now I should change the color to red. Alright. I was scared for a second. I was like, what in the world am I doing wrong? Alright. Yeah, it's not for changing because there's no line here. It's for the reg plot. Now you can see the actual line. So what does this line represent? It's basically the least squared regression line. What does this mean? It means that this is the basically like the line that you can use to predict future values. So for example, the equation of the line, right, is what you can use to predict future reading scores given a certain writing score. So let's say you want to predict maybe the grade of a student who's getting like a 25 writing score. Like, okay, let me rephrase that. Let's say you want to predict the reading score of a student who got a 25 on a writing score. You can do that by using the equation of this line. And how do you get the equation of this line? Okay, 1 second. You go to SciPy. Right. Import, no. You do from SciPy. That is not how you spell Sarai. Okay. Import stats, and then we do stats. Let me run that. And then stats.linregress, right? Something like linregress. And then you just put in the same thing over here. And run that. And it gives you the slope and the intercept. And you are just going to have to know that the equation of a linear regression line, or a least squared regression line, excuse me, is predicted y, or y hat, is equal to a plus bx, with a being your slope and b being your y-intercept. So in other words, it's predicted, really, Sarai? Really? You couldn't spell predicted? Slope plus the y. Wait. Am I going crazy? It's the y-intercept plus the slope. Sorry, my bad. It's the y-intercept plus the slope times x. Great. And then in this case, the predicted y is equal to the intercept. So we take that and we paste that in there, plus the slope, which is this, and we paste it in there, times x, and what else? Yeah, so that's pretty much it. So I'm just gonna copy that and go actually put it in a code and do predicted y, and I'm probably gonna round, actually not gonna round, I'm gonna leave it like that. And let's say I want to predict the y is what you want to predict, so predicted reading score. So let's say I want to predict, let me leave this as writing score. So a student with a, let's say a writing score of 25, and I want to know what the predicted reading score is. I'll just put that in. You're kidding me. Times, by the way. All right. Put that in. Oh my god. What the? Okay, now it should run. Now it's telling me, okay, well, a student that got a 25 as a writing score will have a predicted reading score of 29, which makes sense, right? Because 25, 29, you have a very low scores here. Yeah, it logically makes sense. So that's basically the idea of a least square regression line. You can use it to predict values. Now, there's also a lot more to it in terms of like determining whether you can use this line or not. Like you have to check the actual line and see if it's linear, and if it's linear, okay, but then let's check the residual plot, check R squared, the whatever, blah, blah, blah. We could do that now. Yeah, we could do that. Let me do that. So I could do SNS dot resid plot, which is what I tried doing earlier, but I couldn't because the data was in floats. Rude, I'm telling you. All right, and then just paste that in there, like, you know, same thing, the X and the Y, and it should pop up the residual plot. So now here's the thing. A residual plot, this is like the most beautiful thing I've ever seen in my life. Oh my god. Okay, this is perfect. Okay, so this residual plot is the rules for a good, for like a residual, okay, how do I say this? So again, I said that there are certain like conditions that you have to meet in order to use that line to predict other values, right? Or the equation of a line to predict other values. And so the idea is that you're trying to look for the best fit. So like the best line that fits, or the best equation that fits. And so the better the fit is, the it actually follows these two conditions with a residual plot of that data. So if the residual plot shows no pattern and also the data is centered around 0, then that provides further evidence that that line, or that least square regression line, is the best fit to use as a predictor for other values. So this is like the beautiful thing. Like, oh my god, I can't even. This is like the most beautiful thing. Like literally, it's literally centered around 0, literally, and there is no pattern. In comparison to what I did like 2 days ago, you can see the residual plot, nope, day 328. Hold on, where is it? Here's the residual plot for day 328. You can clearly see that there's a curved pattern, and also the data is not centered around 0. So obviously, even if like the least square regression line, it might seem, yeah, it's very fairly linear, it's not the best fit, because you can see the residual plot, there's a curved pattern, like you see it's curving, and it's also the data is not centered around 0, while over here you can clearly see that there is absolutely no pattern and the data is centered around 0, which is, you know, the line. Right. And so then also, to even further have more evidence to support the fact that this is a best fit least square regression line to use as a predictor, you can also look at the coefficient of determination, which is R squared, which is just your correlation coefficient squared. Okay, I'll get to that. So SNS, hold on, what is it called again? Core? No. Was it SNS.core? Was it PD.core? Or was it SNS.core? I don't even remember. PD.core? Or stats.core? No, data.core. There we go. See, okay. So now what this function does, it gives you the correlation coefficient between each variable. What is the correlation coefficient? It basically tells you how much those the data in those two variables relate to each other or have a relationship. So for example, the reading score and the writing score. So the writing score and the reading score, they relate or have a 95.46% relation to each other. Like their data really correlates. It's a really strong correlation. But if I just take this number, right, I set it equal to my r, and then my r squared is going to be my r squared. So in Python, it's squared by doing two little stars there. Run that, and then paste that. Are you kidding me? All right. This number right here is my coefficient of determination. This number tells me how much variability is explained by this least square regression line. And the more variability that this line can explain, the better fit it is. And because it's such a high number, it's 91.13% basically, you can say that this least square regression line excuse me, I'm like losing my mind right now. I can't even think. This least square regression line explains 91.13% of the variability in the data between those two columns, between writing and reading scores, right? Is that yeah. So because it's such a high number, it's a really good. So we can say that this is really a really good fit to use as a really good line. It's the best fit. It's the best least square regression line to use in order to use a predictor. So I could say that, yeah, like this is a pretty solid prediction of the reading score given a writing score, because there is so much evidence, right, that shows that this is a good, this is the best fit. What else? But yeah, it really, r squared also kind of tells you that it reduces the variability of the line. Like the less variability there is, right, the better, because you're thinking about it like you don't want your data to be very varied, right? Because if it is, then your predictor is not going to be a good predictor, right? Because it's just gonna really assume random things. It's just weird. I don't know. So the less variance, the less variability there is, and the more variability is explained and it's known in the data, the better fit it is. And so that's why, right, because of the coefficient of determination, okay, gotta say that real slow, and the residual plot, and the fact that it's linear in the scatter plot shows that this is the best fit line for predicting, right? Yeah, anyway, I think that's enough for today. I love this. This is really pretty. We did a lot today. Did an SQL, used Parsehub. I really gotta brush off. What? Brush off. Is that even a saying? Brush on. Whatever. I have to work on my skills on Parsehub. Yeah. So anyway. So yeah, turns out in Parsehub, I guess the reason it wasn't working the first time was because I didn't use relation. I had to make sure it was relation. That's why it was weird the first time. We had time, right? And then there was nothing in proportion until time ended, and then proportion data started, which was weird. Okay, whatever. Anyway, that's it for today. Yeah. Bye.